Hello students. So let's go for next video for quick revision for particle in infinite box. So we have learned all this thing in our class. So we have to discuss two type of infinite box. The first is and both have length a, and we should see where we must focus all this thing. So first of all, we have two type of box. The first box is that we can say Vx is equal to 0, x is between 0 to a and infinity otherwise. And this is a schematic diagram for one-dimensional box between 0 to a. And you know the wave function or a solution of Schrodinger wave equation. The solution of Schrodinger wave equation is basically root 2 upon a sine n pi x upon a when you have x is between 0 to a, otherwise 0. And the expectation value of x on any state, that means I am just talking about phi n, x phi n, and this is normalized eigenstate. So this value is a by 2. The corresponding energy eigenvalue En is equal to n square E naught, where n is equal to 1, 2, 3. So you have to always remember this is discrete energy eigenvalue and it should start from n is equal to 1, and where E naught is pi square h cut square upon 2m a square. The ground state energy is E naught. You have this as your wave function. The first excited energy is 4 E naught, and you have this as your wave function. At least you should remember these two wave function, and this wave function is basically root 2 upon a sine pi x upon a, and this wave function is all about, you can write that root 2 upon a sine 2 pi x upon a. The energy eigenvalue is E naught and 4 E naught, because energy eigenvalue is proportional to n square. So you can see the energy eigenvalue is this. The same type is another wave function. You have to also focus on this, that when your potential Vx is equal to 0, and I am just talking about x is between minus a by 2 to plus a by 2 and infinity otherwise. So this is a same width wave function, but we have changed it, and this is symmetric about x is equal to 0. So this is my potential minus a by 2 to plus a by 2. Here your phi n energy eigenstate has two type of eigenstate, root 2 upon a, and that will be cos n pi x upon a when we have n is equal to 1, 3, 5 and so on, and we have root 2 upon a sine n pi x upon a, and when we have n is equal to 2, 4, 6 and so on. This is odd parity and this is even parity. So this cos function is odd. Sorry, this is even parity. So this is even parity. This is even parity. Cos is even function. Sine is odd parity. Odd parity, because here the parity is going to conserve, and obviously 0 other, and this is between these two wave function is between. So these two wave function is between x is between minus a by 2 to plus a by 2, and this phi n x is again 0 outside this potential. So you can have, this is my cos function. So you can just remember this will be root 2 upon a cos pi x upon a, and here this function is again sine function. So this will be go something like this, and this function is root 2 upon a sine 2 pi x upon a. What is the energy eigenvalue? The energy eigenvalue will same as the previous one because width is same. So energy eigenvalue is n square E naught, where n is equal to again 1, 2, 3, and so on. And you have E naught, the value of E naught is again pi square h cut square upon 2m a square. So what you can see? You can see that the wave function is going to change, but energy eigenvalue will remain same. The normalization constant will remain same. And if you are going to calculate average value of x, the average value of x in this case, the average value of x is equal to 0. We know that the average value of x is at the center of box. Here we can also see the average value of x is at center of box, that is a by 2. So this is the qualitative analysis, all this thing. And the problem will always come with related to postulates and all this concept. So you have to also remember some basic integration. So you should practice it hard for that particular integration. I will just give you the formula of this particular integration. And I will just tell you also where you can use this type of integration. And always you can see that this is the ground state is symmetric about center. This is symmetric about center. The first excited state is antisymmetric about center. The first excited state is antisymmetric about center. So this is the qualitative thing. Other than this particular concept, we have to just practice some basic integration, and you must practice that particular thing. So let us go for some important integration which will be useful in this particular chapter. So let's go for some basic integration. So first integration you should always remember, and this integration is all about 2 upon a sine n pi x upon a and sine m pi x upon a dx between 0 to a is nothing but delta nm. Similarly, the second integration is again 2 by a minus a by 2 to plus a by 2. You have cos n pi x upon a, and you have sine m pi x upon a dx. This value is also delta nm. So this is very simple. You can use the orthogonality relation here, but this integration is very important. 2 upon a between 0 to a by 2, and you have sine square n pi x upon a dx is equal to half. So here it is 0 to a by 2. So you should always remember this thing. Similarly, the other main integration is very important, where this thing we can just go for normalization when we are calculating the probability, then you can use this integration. And this integration is also very important. Between 0 to a, you have x, and this is 2 by a sine square n pi x upon a dx is equal to nothing but a by 2. This is all about average value. And again, this integration is also important. X sine pi x upon a and sine 2 pi x upon a dx between 0 to a, and this value is equal to minus 16a upon 9 pi square. So this integration is very important. When you have cross term in the to finding the average value of x, then this type of integration you can have to use. Another integration is 2 by a between 0 to a sorry, this value will be between minus a by 2 to plus a by 2 x cos pi x by a. And again, you can go for sine 2 pi x upon a dx. This value is 16 a upon 9 pi square. So please remember this integration. Another integration is also very important when you are going to calculate some superposition. Let's say ground state and first excited state have superposition, and you need to calculate probability density also. Then this integration is also very useful. So you should just go for 2 by a, just integration 0 to a by 2, and you have sine pi x upon a cos, and this thing is sine 2 pi x upon a dx. That value is equal to 4 upon 3 pi. Just recheck all this integration. The another integration is very important, which can be also asked into your exam. That value is again 0 to a by 2, and this is 2 by a, and you have cos pi x upon a sine 2 pi x upon a dx, and this value is again 4 upon 3 pi. So these are some very important integration you have to always keep in mind, and just do the practice. Please do practice all this integration. This is very important. And you should also remember the some basic concept that average value of x is nothing but the center of the box. So if I have box between 0 to a, if x is the box between 0 to a, then this will be a by 2. If my box is between x is between minus a by 2 to a by 2, then this is 0. And you have to also think that your expectation value of momentum is also 0. Why expectation value of momentum is 0 for any state? Because incoming momentum and outgoing momentum have same probability and same weight. So expectation value of momentum is 0, but expectation value of momentum square is not going to 0. So you have to remember all this thing. And if you are going to remember all this thing, then obviously, and please do this practice. Do practice, at least give half an hour to do all this thing. You can use here integration by parts. These all things are integration by parts. This is just a sine A, sine B formula, and you can directly use it. Please do practice on this particular integration. It will helpful for your exam. Thank you.